Good morning, majors. Today we're going to go over Unit 7, Day 2 notes. This involves special right triangles. There are two triangles that we're going to have to memorize the ratios of, and we're going to go over that right now. So first, let's explore. It says, use the given statement and Pythagorean theorem to fill in the table below. Leave your answers in simplest radical form. So if this is a 45, 45, 90 degree triangle, remember that if these are 45 degrees and they're equal, then my opposite sides will also be equal. So this one will be equal to this one, little b. And if A is 1, we're going to fill in the rest of the information. If A is 1, then B is also going to be 1. And we're going to find out what C is. And we can use the Pythagorean theorem to figure this out, since we are asked for the third side. Remember, the third side in our case is going to be the hypotenuse, and I'm always going to try to make this red. This hypotenuse is red, and I know it's a hypotenuse because it's opposite my 90-degree angle. It's kind of pointing at it, so this is my hypotenuse. So if I look at this, it's going to be 1 squared a squared plus 1 squared b squared equals my red side, or c squared. 1 squared is 1, 1 squared is 1. 1 plus 1 is 2. To get rid of my squared, I've got to take the square root, so I have the square root of 2. And I'm just going to leave it like that. C equals 2. Square root of 2. I'm going to leave it like that. 1, 1, square root of 2. And we're going to explore and do the rest. You know that if A is 2, then B is also 2 because they're equal side lengths. And we're going to use a squared plus b squared equals c squared. 2 squared is 4 plus 4 equals c squared. 8 equals c squared. And I'm going to take the square root of each side, and we're going to get c, take the square root of each side, equals the square root of 8. And you can simplify this. We've practiced this a lot. Put 8 inside whatever is inside the square root, and we're going to pull out the prime numbers. 2 goes into 8 4 times. 4 is not prime. 2 is, so we can't change that one. But 2 times 2 is 4. And remember, when we have a square root, we pull out pairs. And this is going to be my pair. So c equals 2. One pair comes out. And then the square root, if there's one left alone, we just leave it underneath the square root. 2. Alright, so I'm going to rewrite this 2 square root of 2. And let's try one more so you guys can see the pattern. I'm going to use 5. If A is 5, B is also 5. And then C is, let's plug that into the Pythagorean theorem, 5 squared plus 5 squared equals C squared. 5 squared is 25. 25 plus 25 is 50. To get rid of that squared, I take the square root. And I have c equals the square root of 50. We cannot see the pattern unless we simplify it. So I'm going to take that 50 and I'm going to break it up. 50 is 2 times 25. And 25 is 5 times 5. Now I don't have any prime, I have all prime numbers, 2, 5, and 5. I'm going to take out the pairs. So my c is equal to 5 comes on the outside, and then I still have a 2 underneath, 5 square root of 2. So I want you guys to look at this chart and see if you can see the pattern. How does c compare to a? Fill out the next one, please. Our next ratio, our next triangle is going to be a little bit different. Our ratio is going to be different. We have 30, 60, 90 degree triangles. This is a very important triangle also. And this one, they give us 2 of my side lengths. They give us our C, which is our hypotenuse, and they give us an A, which is one of the smaller sides, right? If you see that 30 is the smallest angle, the opposite side is my smallest side. So in this case, A is actually our smallest side. But we're going to look at this. I have a squared plus b squared is c squared. So we're trying to find b. So I have 1 squared plus b squared, whatever that is, equals 2 squared. 1 squared is 1. We don't know what b squared is. 2 squared is 4. Subtract your 1 to move it to the other side. B squared equals 3. And then I'm going to take the square root of each side to get b by itself. And b is equal to the square root of 3. So that might not yet be a pattern. Let's do a couple more. I have a squared is 5 squared plus b squared, we don't know, equals c squared is 10 squared. 5 squared is 25 plus b squared, we're not sure, equals 10 squared is 100. Subtract your 25 to move it to the other side. B squared equals 75. And to get rid of the square root, to get rid of the squared, we're going to take the square root. Okay, didn't make it blue. So b is equal to the square root of 75, but that is not simplified. So we're going to pull out whatever's underneath that square root, which is 75, and we're going to break it up. We know that 3 goes into 75 25 times, or 25 times 3 is 75. If you did 2 wouldn't work, 5 would have worked. If you would have done that, that's fine. You could have picked 5 first. You will get the same answers. 25 is just 5 times 5. So I can pull out the 5's. So b is equal to 5 square root of 3. So I'm going to write this down, 5 square root of 3. And I want you guys to try to figure out the pattern. There's only 2. You can do another one if that'll help. Fill out the rest of this. If you don't see the pattern, fill it out. And then on the bottom, you'll be able to see it. And we'll talk about it in class. So flip your paper over. It says, in order to use the Pythagorean theorem, you must know 2 sides of the triangle in order to figure out the third side. If the triangle is a special right triangle, you only need to know one of the side lengths. So we need to know what to multiply it by, and we'll be able to find out the missing sides, both of them if there's 2. So the 45, 45, 90 degree triangle, it doesn't matter which side they give you. You know that this small side is the same as this small side. So if they give you this number, it says right here, if they give you a number right here, you're going to copy it and put it right here. And you're going to multiply it by the square root of 2 to make it the hypotenuse. Okay? So I'm going to show you that. Actually, I'm going to write out the ratio for you. And we're always going to make this a ratio. Mine's going to be, for the 45, 45, 90, it's 1, 1, square root of 2. Okay? And that's always going to be the bottom fraction. And we're going to use that to solve these triangles. So I'm going to use 1, 1, square root of 2. Remember, the 1's are going to be opposite the 45 degrees. And then the square root of 2 is a hypotenuse, so that's opposite the 90 degrees. It looks like my 45, 90, this one has to be 45, write it in. And opposite my 45 degrees is 3. So if this one is 3, I know that this one is also 3. And my square root of 2 is my hypotenuse, so I'm not sure what that is. So I'm going to put x. I'm going to use these 2 fractions. I'm going to put a box around them. And remember, when I have an equal sign, 2 fractions on both sides of that equal sign, I'm going to cross multiply. 1 times x is x. 3 times the square root of 2 is 3 square root of 2. And I'm done. 3 square root of 2. Okay? And you can kind of see this from the pattern. It's going to be 1, 1 square root of 2. This one is 3, 3, 3 square root of 2. Okay, this one is also a 45, 45, 90 degree triangle, so I'm going to do another one. I'm going to show you guys why it's important to know the ratio. If this one is 45, then this one is definitely 45, and opposite my 45s are the same thing. So if this is the square root of 5, then this one is also the square root of 5, promise. So I'm going to write out my ratio, 1, 1, square root of 2. Put my fraction bars above it, put equal signs in between them. On top of my 1's is going to be my side lengths, or my leg lengths, which is the square root of 5 and the square root of 5. Above the square root of 2 is going to be my hypotenuse, which is always opposite that 90 degree angle, which is our x in this case. Remember, we're going to draw a box around the two. One of them has to be numbers without an x, and then one of them is going to be with an x. That's why we're going to figure out what x is. So I couldn't have used the first two because there's not going to be a variable. And now I'm going to use one with the x and then one without an x. And I'm just going to do it again. Cross multiply. 1 times x is x. Square root of 2 times the square root of 5. What we do is we just multiply underneath the square root. 2 times 5, which is the square root of 10. Okay? And that's it. I don't think you can simplify that, so it's just going to be square root of 10. Let's try this one. This one's a little bit different, kind of. We're just going to solve for something different. So I'm going to have to erase part of it. Let's try this last one. So I'm going to write out my ratios. Anytime I see it's a 45, 90, I know this one is 45. And I know my ratio needs to be 1, 1, square root of 2. And I know I'm going to put my fraction bars above it. Above my 45s, those are my x's. I don't know either side. So in this case, I'm going to put x and x. But across from my 90 degrees, that is my hypotenuse. And this is the one that they give you the hypotenuse, just like number 3. So my hypotenuse in this case is 8. I can't cross multiply the first two again because then they're going to have x on the left hand side and x on the right hand side, and that just won't help us. We have to use one side with an x and then one side without an x. So this one will help. And I'm going to cross multiply. X times the square root of 2 is x square root of 2 equals 1 times 8 is 8. And now I'm going to divide by the square root of 2 because I'm trying to get x by itself and they're multiplied together. So when I divide by the square root of 2, divide by the square root of 2, I'm going to get x equals 8 over square root of 2. And I want you to rationalize your denominator because we cannot have a square root on the bottom. So we're going to multiply the top and the bottom by square root of 2. And you're going to end up getting 8 square root of 2 over 2. And the 2 and the 8 will simplify to 4 square root of 2. That was very fast. We'll get more practice in class on how to do that. Special right triangles for the 30, 60, 90, my ratio is going to be different. It's going to be 1 and square root of 3, 2. I always say it this way, 1, 2, square root of 3. Now, 1, my 30 is my smallest angle, so 1 is going to be opposite my 30. 1 is my smallest side. The square root of 3 is actually my medium side. If you plug that into your calculator, you're going to see that the square root of 3 is 1.73. That is smaller than 2. So some people get confused because they see that 3 is bigger than 2. They say, why isn't that the hypotenuse? But the square root of 3 is my middle length, so that's going to be opposite my 60. And then 2 is my biggest length, so that's going to be opposite my 90 degrees. So I always write it in this order, small, medium, large. Always write it in this order. So you guys are going to help me out now. So I have my small one is, let's just write it down. Small 1, square root of 3, and 2. Put an equal sign in between. So my 1 is going to be opposite my 30. So my 30 is this. So that is going to be 4. And I always do the hypotenuse next. I should have done that red. So my hypotenuse is going to be, maybe we could put y there or x. It doesn't matter. I'm going to put y. That's opposite my 90 degrees is y. And then the other one. So I did my small, I did my big. The other one is going to be above the square root of 3. And I'm going to make this my x right here. And now I'm just going to pick 2 and cross multiply. Remember, I can't have a variable with another variable. That's not going to help us. So I'm going to put a box around these 2 first to start off with. So now we're just going to cross multiply. 1 times x is x, thankfully. And 4 times the square root of 3 is 4 square root of 3. And you don't have to do anything else right here. It's 4 square root of 3, this side length. Now the other one, if you understand the ratio, this one, the small side, is going to be half of the hypotenuse. Then you understand that this is going to be, the y is going to be 8. But let's kind of show you why. So I'm going to rewrite my fractions. I have 4 over 1. I need the fraction that doesn't have an x value in it or a variable in it. And then I'm going to rewrite my y now because I'm trying to find out what y is. And I'm just going to cross multiply again. 1 times y is y. 4 times 2 is 8. So this is going to be the hypotenuse is 8. So if you guys see the pattern on the back, 4 squared is 3, 8. It's going to be the same thing. If you have any questions, I want you guys to try these out. If you have any questions, please ask when you come and see us in class tomorrow.